Okay, go.
Assalamualaikum. This is the our group assignment 3 prepared by Muhammad Ali bin Muhammad, Muhammad Afizuddin and Muhammad Razi. First is discussion on step in each algorithm. There are three algorithms with which are hill climbing algorithm, simulated annealing algorithm and tabu search algorithm. Next, we will show the step of these three algorithms. First is hill climbing. Hill climbing is the most basic local search algorithm. The idea behind hill climbing is to take the current solution and generate a neighbor solution and move to the solution only if it has a lower value of the evaluation function for the minimization problem. The steps of the hill climbing are as follows. Step 1. If the neighbor solution choose better than the current solution, replace the solution with the neighbor. Step 2. If not continue the search. And then step 3. If no better neighbor solution found, the algorithm terminate. Second is simulated annealing. Simulated annealing is a generic probabilistic metaheuristic for the global optimization problem of locating a good approximation to the global optimum of a given function in a large search space. The simulated annealing algorithm was inspired from the process of annealing in metalwork. Annealing is a heat process whereby a metal is heat to a specific temperature, color, and then allowed to cool slowly. This softens the metal, which means it can be cut and shaped more easily. As the metal cools, its new structure become fixed, consequently causing the metal to return in newly obtained property. Then the algorithm proceeds as follows. Step 1 is analyzation. Let x0 equal to initial solution and T0 equal to the initial temperature. Step 2, generate state. When the temperature is TT, do the following. Iteration counter n to 0. So if xi is the current solution, find a solution y in the neighborhood of xi at random. Then just follow as the what this type. Next is a tabu search, proposed independently by Glover 1986 and Hassan 1986. A meta-heuristic superimposed on other heuristics. The overall approach in avoid entrapment in circle by providing a penalizing move which take the solution in the next iteration. To point in the solution space previously visit, hence taboo. Then the algorithm proceed as follow. Step 1 is initialization. Begin with the same initialization used in neighborhood search. Step 2 is choose the termination. Determine a neighborhood and then select a candidate solution from this set that minimize cost. And step 3 is update. Perform update for the search method and then update the history record on a memory record. Okay, next is the parameter setting. First is hill climbing. They have three iteration. First parameter iteration equal to 50, and second parameter iteration equal to 100, and third parameter iteration equal to 150. And then the second is simulated annealing. First parameter is starting temperature equal to 500, temperature decrement 0.99, ending temperature equal to 50. Second parameter starting temperature 1000, temperature decrement 0.99, ending temperature 100, and third parameter starting temperature 500, temperature decrement 0.99, and ending temperature equal to 100. For the tabu search, para first parameter, tabu length equal to 4, count length equal to 4, and iteration equal to 20. Second parameter, the tabu length and count length same with the first parameter, just the iteration equal to 50, and third parameter, the iteration equal to 60. Next is the data use. The data file name is assigned P 800 and cosmetric is 800 times 800. Our group refer the data set from this link.
Okay, next, for the 4.0 is result for each algorithm. So for the three method, for the each method have the 3 iteration, and for each iteration they have 5 time runs. So this is the picture of run. So we do to minimize the result, and the final answer is okay. That is the final answer. So for the first is for hill climbing, iteration 50. First run is 5305. Second run is 4939, and third run is 5629. Fourth run is 6722, and fifth run is 6450. So for the best solution in iteration 50 is 4939. Next, for the iteration 100, the best solution is 5132, and the last iteration for the climbing equal 150. The best solution is 3800 with 6 seconds. Okay, next for tabu search, the first iteration is 20, so the best solution is 4662 with 3 seconds. The second iteration is 50. For the best solution is 5633 with 3 seconds. For the last iteration for tabu search is 60, and the best solution is 4060 with 3 seconds. Okay, for the last method is simulated annealing. So in simulated annealing, we have 3 parameters. So for the first parameter, we start with 500 and end with 100. The best solution is 6119 with 22 seconds. For the second parameter, start with 500 and end with 50. The best solution is 5442 with 23 seconds. And for the last parameter, start with 1000 and end with 500. The best solution is 5354 with 20 seconds. So for the next part, I give to the Razi.
For comparison, there were 3 methods used to find the best solution. Each method has 3 different number of iterations, where for climbing hill, the best solution for 50 iteration is 4939. Meanwhile, for 100 iteration is 5132, and for 150 iterations is 3800. Thus, the best number of iteration for climbing hill is definitely 150 iteration with 3800. Next, for the tabu search, 20 iterations have obtained 4662 as best solution, followed by 50 iteration at 5633 and 60 iteration for 4060. From these 3 solutions, it can be concluded that 50 iterations are the best. Last but not least is simulated annealing, where 6119 is obtained for parameter start with 500 and end with 100. Meanwhile, at parameter start with 500 and with 50, the best solution obtained is 5442, and parameter start with 1000 and end with 500 obtained 5354. out of three parameters, 5354 at parameters type 1000 and end with 5000 has analyzed as best. To conclude from best of each solution, hill climbing has become best of best with 3800. As for closeness to optimal solution, the best solution is 2239, while the best solution close to optimal solution is 3800. That's all from our group. Thank you.